Welcome everybody. I hope you all passed a nice Easter vacation, maybe more quiet than normally, but hopefully still at least sunny and a bit relaxing. This is the second webinar of our new webinar series, which we had always planned to do. And now with the situation being as it is, we've implemented it a little bit earlier. We started last week Thursday, and today we will hear a bit more about key technologies and policy for a climate neutral industry. On the panel with me, you can see Vido Viteka, who's analyst at Agora Energiewende and has been working on the industry topic since more or less the beginning of his time with Agora. You can see Christoph Podewils, who's Director of Communications and who will support me during the Q&A session at the end of the webinar. And we also have Janne Görlach, the trainee at the Communications Department at Agora Energiewende, who will take care of everything else that neither Christoph nor I can deal with. My name is Nicola Bock. I'm the Head of Events at Agora Energiewende. The webinar will last for about an hour, and we are now starting with the introduction. I will also inform you about the venue and the housekeeping, and then I will hand over to Vido to start the presentation, which will last for about 25 to 30 minutes. And after that, we have ample time for your questions and remarks. Talking about questions, at the bottom of your screen, you have two menu buttons. On the left-hand side, you see the chat button. On the right-hand side, you see the Q&A, or if you have it in German, then it's F und A für Fragen und Antworten. You can use the chat in order to let us know any problems or things concerning the technical surroundings, so Zoom, in case you have problems with the audio or the video or anything else, you can put it in there and we will try to help you as much as possible. We will use the chat function in order to inform you about relevant links. For instance, you can already download the presentation that Vido is going to show in a minute on our website. So in case you face a slow internet connection or something, you can download it from there and watch it there. We also share the link to the publication, which has actually been published already at the end of last year. But it's the first time that we do a public presentation of the topic in English. So that's the chat button. Everything you put in the chat button can only be seen by us four. On the right, the F&A or Q&A button you can use for your content-related questions. So any questions and remarks that arise during the presentation of Vido, just put them in there, and we will try to address as many as possible. During the webinar last week, we had some 60, I believe, so I'm afraid we may not be able to answer them all during the webinar, but we will receive them afterwards in writing and we'll make sure that you get an answer at some stage at least. Information for you, the questions that we will address from the Q&A session will be made public once we have answered them. So just that you know. And last but not least, you can already see that we have started the recording because we would like to make this webinar available also for people who cannot join right now. So in case you do not want to leave any footprints in the World Wide Web, I kindly ask you not to pose any questions in the Q&A because as I just mentioned, they may become available for, I mean, the other participants may be able to see that, and also it will be in the recording. Right, I think that's it from the housekeeping and introduction side. Before we start with the presentation, we have again prepared a little poll for you, which I will start right now. The question is, and I will make it available for you as well. Right. You should be able to see it on your screen now. The question is, by when do you think industry can become climate neutral in your country? So this is just whatever you feel, whatever you think, just to get an idea about how optimistic you guys out there are. And at the moment, you do not see anything, but I do. I see that most of you seem to be convinced that by 2050, we will become climate neutral. I will just wait a little more till I see no more answers are being given. I think I can stop. I'll give it another 5 seconds. And I will stop the poll now and make it available for you. So you can see, by when do you think the industry can become climate neutral in your country? I will repeat it because I've realized last time that the recording doesn't actually record the polls, so I will read it out loud. By 2040, 25%, so a fourth of the audience think that. Almost 50%, 46% to be more exactly, anticipate that by 2050, the industry in their country will become climate neutral. Some less optimistic, 19%, so almost every fifth of us, of you, consider it will be climate neutral by 2060. And 9% think it's gonna happen later than 2060. Okay, so Vido, I think this is a good start to hand over to you. I will close the poll and leave the stage to you.
My name is Vido Witeka. I work as an analyst for Agora Energiewende on the topic of industry decarbonization. And today I will present some of the key insights of our study, Climate Neutral Industry, that has been published in German in November last year. As Nicola mentioned, this is the first time that we are presenting the content to an English-speaking audience. And you may have seen that so far the executive summary of the study in English is already available online, and we're currently working on the translation of the entire study and will publish that as soon as possible. The study was done together with the Wuppertal Institute, who was responsible for the modeling exercises and well, in-depth knowledge of the technologies. And I will jump into the presentation right now. Looking at it from a global perspective, when it comes to decarbonization efforts, the industry sector has long been left out of the discussion. This is for a number of reasons. One is that when it comes to industry, people often talk about the so-called hard-to-abate sectors, so steel, cement, and chemicals. That is because they have a rather high share of process emissions, which are hard to mitigate, and entirely new production processes are needed, which are also rather expensive from today's point of view. A second reason is that there are different emission allocation methods. One is the direct emissions per sector. You can see on the left-hand side that industry accounts for roughly 20%. However, if you look at it from an end user sector perspective, where the electricity and heat demand are allocated to different end use sectors like buildings, transport, and industry, you see that industry is already by far the largest sector. And we also expect that this will continue to be the case in the future. One reason for that is that there's a rising global demand for basic materials. So projections show that steel demand and cement demand will be increasing, mainly because of infrastructure needs and emerging and rising economies. And also ammonia as a basic input material for fertilizers. Also plastics are projected to rise because of a growing world population. So from this, we can already take away that avoiding process emissions is key. And due to the long lifetimes of industrial plants, which I will get to later, future reinvestments have to be into new technologies. Otherwise, we won't reach the goals of the Paris Agreement. Now, if you zoom into the industry sector, you can basically see that 3 sectors are responsible for the lion's share of emissions in the industry sector. That is steel, the purple part, iron and steel in the graph, then cement, which is the lion's share of other metals and materials, and plastics and fertilizers, which is the chemical and petrochemical part in the graph on the left side. Then if we look at where most of the emissions are emitted, if it comes to industry, you can see on the right-hand side that China accounts for almost 50% of global emissions, industry emissions. Second is Europe, followed by India, the US, and Japan. This is the global overall picture. Now I go to the content of the study. The study was focusing on Germany only, but I believe there are a number of takeaways that are also important and interesting for a European or even global audience. So in Germany, industry is responsible for about 1/5 of total emissions. You can see that on the left-hand side. And similarly to the global picture, around 60% of these emissions comes from the sectors iron and steel, cement, and basic chemicals. And we also decided to focus on these 3 sectors because they make up the highest share, but also all 3 of them account for relatively high share of process-related emissions, which you see in the middle. Overall, around 1/3 of the emissions in the industry sector is process-related. And as I said before, we will need fundamentally new processes to get rid of these process emissions. Another interesting fact when it comes to industry decarbonization is that in Germany, industrial emissions remained rather constant since 2000 or 2010. And this shows us that despite energy efficiency measures, emissions are not declining, or emissions have not been declining over the past years. Energy efficiency measures still remain important, but they were only able to compensate for parts of the production growth because we had stable economic growth over the past years in Germany. And I think this is potentially also something that applies to a global scale, that energy efficiency can help to reduce emissions. But if we believe in continued economic growth in many regions of the world, energy efficiency is not sufficient for a climate neutral industry. And on the right-hand side of the graph, you can see the different sector targets for industry, the year 2030 and the year 2050, a climate neutral industry by then. So you see that trending sideways is not enough to reach these goals. Now, what could be strategies and technologies then to enable a climate neutral industry? I mentioned already before that in order to avoid process emissions, we probably need fundamentally new processes. We identified 9 different strategies that in our view enable a climate neutral industry. And it's also possible to cluster them into 3 different groups. So one group is the strategy or the cluster direct and indirect electrification. One way would be the direct use of green electricity. And another way would be the indirect use of green electricity through the production of green hydrogen. The second cluster is resource efficiency and circular economy. Circular economy will play a vital part in decarbonizing industry because it has a major effect on the energy efficiency of producing goods, It has a major effect on the resource efficiency of producing goods. And probably without circular economy, it won't be possible to reach net zero by 2050. Then there are other options like material efficiency. So for example, using less material in order to get the same results, or material substitution. One example is building with wood instead of cement, for example. And then there's the last cluster, the third one, closing the carbon cycle technologies like carbon capture and storage, carbon capture and use, and also the use of sustainable biomass. And when you look at these three clusters, what is also noteworthy is that they're interdependent to a certain extent. That so if you put less emphasis on electrification and green hydrogen, you know already by today that you will need more of the other measures. So for example, carbon capture and storage or circular economy measures. What we then did in the study is to look at key technologies for the three main branches, so steel, cement, and basic chemicals. What you see here now are the key technologies for basic chemicals that we identified. And you can also see again that they are different strategies, different technologies that can be allocated to the different strategies that I mentioned. I do not want to go into the details of the technology here, but you can see that it's also a portfolio of different options that we have. And another important thing is that most of these technologies are not market ready yet. That means that they're still in technology development, but they could become ready by 2025 to 2035, at least most of them. For the steel sector and for the cement sector, we did the same thing. You can see the technologies that we identified. For steel, we think that hydrogen will play a central role, mainly because we think the direct reduction with hydrogen is a very promising technology that can deliver vast emission reductions in the steel sector. And for cement, from today's perspective, there's a role for alternative binders, which would lower process emissions or avoid them altogether. However, we think there will probably only be a small market share in the future. So for cement, because process emissions cannot be avoided, we also think that CCS technologies will play a vital role in the future. For all these 13 technologies in the study, we developed brief technology fact sheets where most of the important information are summarized. You will see that once the study is available in English online. And these information included CO2 abatement costs of the technology, the CO2 abatement potential, the technology specific costs in comparison to the conventional technology, existing pilot projects where companies are working on developing these technologies, and reinvestment cycles and the technology readiness level of these technologies. You can see one example here. That's a snapshot out of this technology fact sheet where we compared the conventional steelmaking route through the integrated blast furnace route and the direct reduction with hydrogen, where you can see you can reduce emissions up to 97% in the long term. But even for the year 2050, that is illustrated here, there will be additional costs for this new technology. And this will be the topic of the second part of the presentation, that how these additional costs can be covered by policy instruments. This is another graph from the technology fact sheet that I think is important. What we see is that there are very high reinvestment needs in the industry that are the gray bars in the lower part. So you can see that there's a big reinvestment need, especially in the years from 2025 and 2030. And on top, the blue arrow, we have the technology readiness level scale of the new technology, the direct reduction with hydrogen in this case. So currently it's in a state where pilot plants are built. Soon demonstration plants could be built. And in a very optimistic case, we think that by 2025, this new technology could be ready for the market from a technical point of view. If there's not enough green hydrogen available, then it would also be possible in this case to start with natural gas. And if you think the two of them together, it is very important that we do not miss the reinvestment cycle between 2025 and 2030 in the steel industry, because the alternatives to that would be not so good, I guess. One alternative is that companies decide to invest into the old conventional technology again, which would leave them in the system for a very long time. And the other alternative is that if they don't see a business case to invest in the old technology, but also there's no business case for the new technology, then maybe they wouldn't invest at all, which from a German perspective or a European perspective might mean that this steel production moves abroad with potentially higher emissions than is currently the case in Germany and Europe. This is a slide to wrap up the first part of the presentation on the strategies and technologies. German industry is working on numerous pilot projects, but I could also extend the case and say European industry is working on numerous pilot projects, because there's also a lot going on in Sweden, in the Netherlands, in Austria, in France. But what is missing is the right framework conditions to enable large-scale commercialization and the deployment of these technologies. And this will be part of the second part of the presentation. But before we jump into that, there will be another survey on the policy instruments before I start with that part of the presentation. So I hand over to Nicola again.
Yeah, I just needed to unmute me. Thanks, Vito. I will call upon the next poll, which you should be able to see right now. The question is, what policy instruments do you think are suitable to create an investment framework for low carbon technologies? We have 4 possible answers. The first is high CO2 price with border carbon adjustment. The second one is policy mix scenario, for instance, carbon contracts for difference. The third one is other policy options. And the fourth one is no further policy support needed. And I can see people are still voting. We are, by the way, we just hit the 200. So even though you only see us 4, you're not alone. We're 200 and more than 100 already voted. But it looks like almost everyone has made up his or her mind. So I will stop the poll and make it available for you. So as you can see, the first answer, high CO2 price with border carbon adjustment, was sort of won. Well, 48%, so 67 people voted for this option, but it's closely followed by policy mix scenario, for instance, with carbon contracts for difference, which 65 persons, so 46% deem feasible, and only 6%, 8 persons in total, voted for other policy options. So now we are excited to see what Vito will present. In a minute, I will finish this and hand over back to you, Vito.
Thank you, Nicola. This is one of the most important key messages of our study. If you look at the industry sector and specifically the 3 sectors, steel, cement, and chemicals, all plants have very long technical lifetimes, between 20 and 50, even up to 70 years. And that means if there's a reinvestment cycle coming up in the 20s and you need to reinvest your plant, then if you invest into the old plant, it will still be in the system far beyond 2050, which is of course incompatible with a climate neutral industry by the year 2050. That means any future investments from now on must be climate neutral, otherwise there's a risk of a carbon lock-in or stranded assets that these plants have to be shut down before the year 2050. We also saw in the study that there is a very high reinvestment need in Germany's energy-intensive industry until 2030. I talked about the steel sector already. So 53% of primary steelmaking capacity will have to be replaced by the year 2030. If you look to the chemical sector, it's roughly 60% of the steam crackers. Here the case is a little bit different. There's no very clear cutoff date when a steam cracker needs to be reinvested as in year X, because it's also possible to only change components and prolong the lifetime a little bit. But it also gives you a rough impression how old these plants are in Germany. So there is definitely a need for modernization. And in the cement sector, it's also 30% of the cement kilns that have to be reinvested by 2030. If you turn to the right side, you see the direct employment of these industries, so steel, chemicals, and cement. And these numbers for Germany are rather large. So a lot of people are affected by these reinvestments and by the strategic decisions that are now taken by the companies, but also by the governments via a policy framework. And maybe just a noteworthy comparison, you probably know about the coal phase-out plan in Germany. In the entire coal sector, I read studies that 20,000 people are affected by these policy and structural change. So you see that in the industry, it is much more than that. If we look at the costs of the new low carbon technologies, we see that all of them, or almost all of them, have significantly higher costs than the conventional technologies. So you see, for example, the direct reduction with hydrogen in the steel sector with almost 100 euros in the year 2030 and the lower range. So it's also possible that it might be more expensive. You see other technologies. And what is important to take away from this slide is that most of the technologies will be more expensive than the conventional technologies. And the CO2 price in the EU ETS, which before the Corona crisis stood at around 25 euros, is not enough to introduce these new technologies to the market. That's why we believe other policy instruments will be needed. Just a short word on the exceptions. So steam from power to heat is a technology with negative CO2 abatement costs in our calculation. But this is because we had very specific assumptions that power to heat can be operated in combination or in hybrid combination with natural gas boilers and only used in hours where there's a high share of renewable electricity and electricity prices are rather low. Only in that case and in a limited amount of hours you reach these negative abatement costs, but we still think it's a promising technology for the next years. And also with chemical recycling, it could also have negative abatement costs, but the largest share of emissions reduced with this technology are not in the chemical sector actually, but with thermal incineration plants, because that makes up the largest share of emissions when you look at the plastics value chain. So there are still some regulatory obstacles before you can implement these technologies and have a business case for that. So now, if these technologies are significantly more expensive and the EU ETS or the carbon price signal is not enough to bring them to the market, what are potential policy options? We saw already in the survey that most of you actually opted for one of the two options here that we identified in the study. One is a high CO2 price with a border adjustment regime. Most of you will know that this is also something in the discussion in Europe now, because the European Commission opened a consultation process on this proposal as part of their Green Deal communication. And then there's the second option, policy mix. I do not want to go into the details of all of them, but just highlight a few. One is, for example, the carbon contract for difference that could cover the additional costs of specific technologies. We will go into the details of this one later. Then there's the idea of securing sales markets for green products or feedstock. So either green hydrogen through a quota, or the quota for low carbon materials, and green public procurement, which probably most of you will have heard as well. And another important set of policy instruments, circular economy standards, to make sure that circular economy really plays a vital role in our industry decarbonization efforts and in the industry transformation. Now, when you look at these policy instruments from an industrial value chain perspective, you can also cluster them a little bit differently, and this is what we tried here. So you have the different parts of the value chain: upstream, midstream, and downstream. What is important upstream is internationally competitive prices for green electricity, the green hydrogen quota that we looked at in the study, and also the development of infrastructure, for example, for CCS, for hydrogen, but also transmission grids for electricity. Without these, it's not possible to decarbonize industry. Then there are midstream instruments, like, for example, the carbon contract for difference that could cover additional costs for producing green basic materials. And then on the right-hand side, you see a number of instruments that could apply downstream. So either a quota for low carbon materials, let's say, for example, the government obliges car manufacturers to use 10% of green steel in their cars, and this quota is rising over time. Basically, the same idea is on the bottom, green public procurement, where the state obliges itself to use green materials for building state infrastructure projects like bridges, streets, and other things. And then there are the ones in the middle. So a consumption charge on end products, where people would pay only a small premium to finance, for example, a carbon contract for difference. That is the idea that I will present later. There could be a carbon price on final products. And then again, standards for recyclable products and changes of construction and product standards, again, the circular economy instruments. If we look at option one again in a little bit more detail, we see that the high CO2 price with a border carbon adjustment is definitely an option. The idea is that there would be a high CO2 price in the European Union, and if basic materials are imported to the European Union from other countries that are not subject to a CO2 price or a lower CO2 price, they would have to pay carbon adjustment upon importing to the European Union. An open question is whether if producers from the European Union they want to export to other countries could get an export or a border adjustment relief, because from a WTO law perspective, it is questionable whether this is feasible. The biggest problems with these instruments we see from a political point of view, that it may fuel trade conflicts if the European Union was to say, we have a border carbon adjustment scheme based on climate reasons. Maybe other regions of the world, such as the US and China, will do that for other reasons, national security or whatever reason you can imagine. And there are also practical hurdles that in order to define the CO2 content of different basic materials coming into the European Union, you would need tracking of the CO2 content, basically globally. And we also think that this is a very difficult administrative task, and there's also room for fraud. That's why we looked at the different option, which is a carbon contract for difference to finance the additional costs for low carbon key technologies. And the money needed would come from a climate surcharge on end products. So if you look at this slide, what you see on the left-hand side is that the steel, green steel, for example, is more expensive than the conventional steel. And because there is fierce international competition, steel is a globally traded commodity, it's not possible for the green steel producer to pass on these costs to the consumer. However, if you actually look, how much would it cost for the end consumer to pay for green steel in an end product like a car? It's actually only 1% of the product price. So in this calculation done by the Energy Transitions Commission, they said a car with green steel would be $180 more expensive than a car with conventional steel. And this, if you consider a purchase price of around 20,000 euros for a new car, would only be 1%. So the idea could be that you raise money there, let the end consumer pay a little bit for the green materials, and then this money is used to finance the carbon contract for difference. From an industry perspective, how could this look like? So here's an illustration how this could work for the steel industry. You see on the left-hand side CO2 intensive steel production through the blast furnace route with around 1.7 tons of CO2 emissions. This could be reduced by 1.5 tons of CO2 in a first step with the direct reduction with hydrogen technology. Then later on, even more. But the assumption here was that it's only 65% hydrogen and still a share of fossil-based methane. And for this new technology, there are CO2 abatement costs, break-even costs in the steel production of around 100 euros in order to create a business case for this new technology. And the idea of the carbon contract for difference is that it would cover the price gap between the CO2 prices within the EU ETS. The assumption here is that there's still free allocation for this plant based on the old conventional benchmark. So if the steel producer actually emits less, he could sell most of these emission certificates that he got for free on the market. And whatever the difference is to the break-even price that he needs to have a business case, that would be covered by the carbon contract for difference. In this example, 50 euros per ton of CO2. So now I come to the conclusions and some questions for discussion. We have seen that the 2030 sector target for German industry is already very ambitious. And then if we look into the future climate neutral industry by 2050, will be even more difficult. So if we assume continued economic growth, efficiency improvements alone won't do the job. We need fundamentally new production processes and technologies to achieve climate neutrality in industry. A lot of companies are working on these technologies, and I'm rather confident that within the next 5 to 10 years, a lot of them will be ready for the market from a technical point of view. What is really missing is the policy framework that enables a business case for these new technologies. And this is critical if we want to achieve the sector targets for industry 2030 and 2050. And also, what changed maybe from the narrative a few years ago when it comes to industry is that because of the long lifetimes of these plants, we have to invest into these new technologies as soon as possible. It is not possible to first focus on other sectors like the power sector, the building sector, and then decarbonize industry in the year 2040, because that would mean that you would have to decommission a lot of plants that are still fine from a technical point of view. So questions for the Q&A discussion that I propose, but of course you can ask any question that comes to your mind. The questions that we think of in our current work is which policy instruments are best suited for a climate neutral industry. And of course, this topic gets rather complex if you go into the details of implementation of different policy instruments. Then the second one, what should be the relationship between the EU ETS, so a classical carbon pricing instrument, and potentially new instruments? And also, what is the likely time frame for the introduction of these new instruments? Because as we saw, if there are reinvestments coming up in the 20s, it is rather urgent to come up with a suitable policy framework in the near future. Thank you very much. This was my presentation, and now I'm happy to answer your questions.
Thank you very much, Guido, for this presentation, also within the time frame. So we have another 20 minutes now for the questions which have already come up. I can see we already received more than a dozen, but you can obviously still put your questions into the Q&A or the F&A window, and we try to cover as many or address as many of them as possible. I will now hand over to Christoph, who kept an eye on those. Christoph, can you unmute yourself?
So again, probably you did not hear me, so I start over again. So thank you to both of you, Nicola and Guido, for your presentation and the kind introduction. So we have already a couple of questions regarding on techniques on the one hand and on policy on the other hand. So I would propose to answer on the technicalities first. And one request to you who have asked already questions in the chat section, so in the Zoom webinar chat, I would like to ask you to put those questions again in the Q&A section or the Frage- and Antwort-Bereich, because otherwise we are not able to handle all those questions. It's rather a lot. So, Guido, the first question I would like to pose is by Adam Köhler, and it's on combined heat and power technologies in the chemical sector. So which fuel do you assume to be carbon neutral in the future for combined heat and power?
Okay. So when it comes to combined heat and power plants, our assumption was that they might still be operated with fossil-based natural gas, but then you need a carbon capture technology to sequester the CO2 and then store it long term. So the technology that we looked at in our report was actually carbon capture and storage, or carbon capture at combined heat and power plants in the chemical industry. Of course, it's also imaginable that in the future there could be some kind of synthetic or green gas in these combined heat and power plants, but in our view this would be much more expensive, so that's why we opted for the CCS option, and we did an in-depth analysis on this technology.
Okay. Thank you, Guido. Then a more general question by Sanjeev Kumar. I hope I pronounced that good. He asks, what is green hydrogen? Why does Agora use this definition?
Yeah. So green hydrogen, or what we refer to as green hydrogen, is hydrogen that is produced from renewable electricity. So mainly PV and wind. And this is referred to as green hydrogen in the discussion because this is a technology where it's possible to really reduce the emissions at a rate of 100% compared to conventional hydrogen production technologies that are either based on coal or on natural gas.
Thank you. The next question is by Ken Hüstebeek, maybe. Question on chemical recycling. You have focused on gasification and pyrolysis. Do you plan to also look at depolymerization, e.g. of PET and PS? So it's chemical recycling of plastics, I guess.
Yes, very interesting question. So indeed, we focused on the pyrolysis and gasification processes. We have not looked at other processes so far, but we are aware that there's a lot of research and development going on. So this is definitely something that we would like to look into in greater detail in the future. And also very happy to have an exchange on that if you are working on these topics and we can learn more about this.
So another question by Sanjeev Kumar. Why did you not look at renewable heat from geothermal energy, for example, to meet chemical sector demand?
We looked at renewable heat because we included power to heat as a technology in the portfolio to decarbonize the heat in the chemical industry. Geothermal was not a consideration because the potential in Germany, to my knowledge, is rather limited. But of course, this does not mean that this is not a promising technology in other regions of the world where you have different potentials.
Thank you. Next question by Timo Gerres. To what extent does carbon capture play a key role in industrial decarbonization? How did you evaluate the cost of storage, and what would be the consequence for your scenarios if CCS would not be available because of society rejecting this option? So I guess it's more than one question, actually.
Yeah. So, as I mentioned before, we think that for cement production from today's perspective, CCS will probably have to play a role in the decarbonization of industry. There are other concepts like, for example, the recarbonation of demolished buildings, which is a CCU technology that is also very promising in my personal opinion. But I think generally we will need some kind of CCS, especially for the industry sector and for the cement sector. So we will also need to build up infrastructure, and we're currently in discussions and in different projects where we evaluate how high the share of CCS will have to be. If CCS is not available as a technology, it becomes extremely difficult to reach the targets within the boundaries of the German system, because there would be residual emissions in the cement sector for sure, but also potentially small fractions of residual emissions in the steel sector, in the chemical sector. And if we had to compensate them through, for example, afforestation, I do not think that it would be possible to do that in Germany. Then it would rather have to be an international solutions. That's why we also think CCS has to be to some extent in the portfolio of options.
Thank you. One little remark from my side. Some of you are still answering questions via the chat function. We are not able to answer those questions right now via the chat function, so please put them in the Q&A section of Zoom, in the Frage- and Antwort-Bereich. Okay, one last question regarding technicalities, and it's by Martin Albiker. Which share of the required green hydrogen for industry do you assume Germany would be able to produce domestically, and how much would need to be imported?
Yeah, so we haven't made detailed assumptions regarding that question in the climate neutral industry study. But we have done so in another study, 15 Eckpunkte for a climate law. And there we proposed the idea of a green hydrogen quota where roughly, I think, half of the green hydrogen should be produced in Germany through electrolyzers, and the rest could be imported from other countries. But there's not a very clear position yet where I could say this is the exact share that we think can be produced in Germany. I think in the long term, Germany will probably have to import the largest share of hydrogen from other countries.
Okay, thank you. So let's switch to the political part of the Q&A session. And the first question I have chosen is by Georgia Concas. Is there a need for an EU and/or German industry strategy for hydrogen and/or CCS, considering that while playing a potentially big role in cement, steel, and chemical industries, these technologies will or should play a very marginal role in all other economic sectors? Isn't there a risk that these technologies are used to keep gas and coal plants and infrastructure in place? So the question is basically on the need of industrial strategy for hydrogen and CCS.
Yes, I think it's a very good question, and my personal opinion is that we need some industrial strategy. There are also already some companies and groups working on the topic of hydrogen and hydrogen infrastructure. I think on a European level, it is also important to bring back the CCS debate and really look how countries can cooperate with each other. To my knowledge, the Netherlands and the UK and Norway are countries that may be willing to store carbon in offshore fields. So there's a case for Germany, but also other European countries to really think about developing this kind of infrastructure, either through ships and vessels, for example, along the Rhine River, but also pipeline infrastructure. And then one needs to assess what the infrastructure need really is. Regarding the question whether this will basically lock in coal and gas infrastructure, I can only answer for the case of Germany. I think in Germany, the discussion whether CCS could be applied to coal power plants is dead. I do not think that this will happen in the future. And then regarding gas-fired power plants, we still have to see. There might be a case for some CCS if they're, for example, in the chemical sector. And I briefly mentioned our ideas and discussions regarding CCS at combined heat and power plants. But I also think that for sectors where there are alternatives available, like electrification, like green hydrogen, and others, that this should be the priority, and CCS would not be a solution where you decarbonize, let's say, 70% of the industry sector, but rather a solution for sectors where you really have no other alternative than that.
Thank you, Guido. The next question is by Gotcha Mette, and he or she is asking, isn't carbon adjustment policy incompatible with the spirit of Paris Agreement? And does it count consumption emissions unlike production emissions? So is there a difference between consumption emissions and production emissions?
Well, I guess I would have to think about that a little bit more. It's a difficult question.
Okay, let's take it as an impulse for further thinking, and okay, maybe we will have a discussion later on one time. So next question is a little bit same direction. It's by Sasha Gajewski, and he asks, why would a CFD scheme not lead to trade conflicts? Because it implies as well a direct intervention into the market by their subsidizing companies with a generated income. So CFD and trade conflicts.
Yes. We think that the CFD is different from the border adjustment mechanism in a sense that in the beginning it would only apply to probably a small share or a small number of companies that work on these technologies and really have a market introduction for these new technologies that we know will be needed to decarbonize industry. However, this would not affect the trade flows in the first place, because conventional steel from other regions of the world, let's say China and the US, could still be imported to the European Union at the same price, and the CFD would only cover the cost differences between the conventional steel in the European Union and the low carbon steel. And would therefore create a business case for the new technology. And the other reason is, let me think about that. It was about and the other reason is that you don't need a tracking of the CO2 content for the imported basic materials, which, as I mentioned in the case of the border adjustment scheme, really creates a lot of administrational headaches on how to do that on a global scale.
Okay, thank you. The next question is by Wilfried Seifert, and basically he is asking if Germany or Europe is importing hydrogen, green hydrogen anyway from other regions, how can we prevent that basic industry does not move to countries which produce that alternative power already?
Yes, this is also a very good question, and I think there's an industrial policy angle to that as well. So I think there's definitely the opportunity, or also the risk from a European perspective, that if green hydrogen is produced in other parts of the world and it is produced cheaper than in Europe, that some of the production, industrial production, may also go to these regions. But if they produce then with this clean feedstock of green hydrogen, I think that is also a good thing, because overall we still believe and we see the projections that the demand for basic materials is going to rise over the next years because of a growing world population, because of growing infrastructure needs in emerging and rising economies. Therefore, I think if part of the production is done close to the sites where green hydrogen is produced competitively, that is a good thing. It does not necessarily mean that production in Europe also is lost. I think there can be a case where we remain the same share of primary production capacities in Europe and import some of the green hydrogen.
Thank you. So I want to come to the last question with regard to the clock. And as we did not talk on Corona over the last hour, which is very nice, I think one question regarding Corona would be okay, because also it's a forward-looking one. How much do you think the ongoing pandemic would affect the policy options? For most of the industries now, the priority would be production.
Well, that's also not a question that is easy to answer. I'm nevertheless going to give it a try. I think that a green stimulus package or a green recovery has to be at the center of all the policy measures when you think towards the near future and how to get out of this crisis. We also see that industry is heavily affected by the corona crisis. But if you go, for example, back to the idea that there is a very high reinvestment need in certain parts of the industry, like the steel sector, like potentially the chemical sector, it is also clear that just waiting and not doing anything will not create a future-proof solutions for these companies. So that's why we think there is still a need to go and implement this policy framework rather sooner than later, because once you miss the reinvestment opportunity, I mentioned before, then you're on track with two not so nice scenarios, which is either the carbon lock-in because you invested into the old technology, or that you do not invest at all because there's no business case for the new technology. And if you really think about the reinvestment that should be made by the year 2025, then policy that creates this kind of framework needs to be in place in the next 2, 3, 4 years. Otherwise, these reinvestments will not happen into the new technology.
Yes, thank you, Guido. And more on that you can hear on Thursday when our director, Patrick Reiche, will join the Digitales Kolloquium. So this is a webinar series by Deutsche Energieagentur, DENA. And he will talk about our recent proposal on a double booster or double stimulus to recover the economy in a green and climate-friendly way. So this is on Thursday on 5 p.m. Central European time. So thank you again, Guido. And now I would like to hand over to Nicola again.
Yes, thank you, Guido, for this interesting presentation and also for answering at least a quarter of the questions that were raised. We will try to answer some of the other questions or the rest by email. If you still have open questions, just send them to webinar@agora-energiewende.de. You should still see the email address in the chat window. Also the links to the presentation on the website and to the executive summary of the study. If you ever want to find out what webinars may be upcoming and which webinars have already taken place during our Agora webinar series, just visit our website. In the events section, you can find everything which is public so far and will be continuously feeding it. On Thursday, we have another webinar which is on, let me just double check for the title. It's on CO2-oriented energy pricing, lessons learned from the German debate for the EU smart sector integration strategy. And this will be held by Thorsten Lenk and Andreas Graf from our Germany and the EU team. It starts at 3 o'clock, and of course we still have places available. There'll be more webinars upcoming next week, Tuesday and Thursday. They're already in the pipeline, not public on the website yet, but will be in the course of the week. I hope you enjoyed the webinar and can take away a few insights. And I'm sure, Guido, we will hear more of this on the topic within the next month and years, because you and the industry are working on that, I can imagine. So everybody have a good afternoon, rest of the day. Thanks for tuning in and see you next time. And thanks, Janne and Christoph also, of course. Bye.